Welcome to another video by the Security Buddy. In this video, we will discuss what the regression sum of squares, the sum of squared errors and the total sum of squares in linear regression are. Let's say we are given two random variables x and y. X denotes the heights of persons and y denotes the corresponding weights of those persons. Let's also assume that x takes the following values and y takes the following values. Now, we can use linear regression to find an equation using which we can calculate the value of y for a given value of x. Let's say, using linear regression, we get the following calculated values of y. Please note that capital Y here represents the observed values and capital Y hat represents the calculated values or fitted values of y. In other words, we can draw a scatter plot of x and y. Then we can draw the regression line. The points in black represent the observed values of y. And for a particular value of x, say xi, we can find a point on the regression line. That point will represent the corresponding fitted or calculated value of capital Y, say yi hat. In this graph, the red points are the fitted values of capital Y or capital Y hat. And the difference between the observed value of y and the corresponding fitted value of y is called the error or residual. In other words, if we were given endpoints, then residual or ei is equal to yi minus yi hat for I in between 1 to n. In this graph, the red lines represent the residuals. At this point, if we square the residuals and sum them up, we get the sum of squared errors or SSE. So, SSE is equal to summation from I is equal to 1 to n yi minus yi hat whole square. Now, let's say y bar represents the mean value of y. So, y bar is equal to summation from I is equal to 1 to n yi by n. At this point, if we take the difference between yi hat and y bar, square them and sum them up, we get the regression sum of squares. In other words, if we are given endpoints, then the regression sum of squares is equal to summation from I is equal to 1 to n yi hat minus y bar whole square. Please note that here we are representing the regression sum of squares with RSS and the residual sum of squares with sum of squared errors or SSE. Now, if we take the difference between yi and y bar, square them and sum them up, we get the total sum of squares or TSS. In other words, if we are given endpoints, then TSS is equal to summation from I is equal to 1 to n yi minus y bar whole square. Please note that the regression sum of squares plus the sum of squared errors is equal to total sum of squares. And if we calculate RSS by TSS or 1 minus SSE by TSS, we get the value of R squared. In other words, R squared is equal to 1 minus SSE by TSS is equal to RSS by TSS, where RSS represents the regression sum of squares and SSE represents the sum of squared errors or the residual sum of squares. I hope this helps. Interested viewers who want to know more, please refer to the playlist Linear Regression or visit the website of the Security Buddy. The relevant links are provided in the description. You may also want to subscribe to us and get notifications of recent videos.